Yo, listen!
I haven't seen you in a long time, bro.
Hey, how you been?
Good. Well, how about you?
Yeah, this way. Hey, you wanna play some Mario Kart?
Yeah.
Alright, let's go, man. Hey, so you good at Mario Kart?
Yeah, I'm pretty good.
That's so cap.
No, I'm okay. Alright, let's play.
Alright, I'm gonna go turn on the TV on real quick.
Alright.
Which controller you want, man?
Any?
Alright, take the red one. Oh, what the heck is on the game? Alright, there we go. Alright, ready to play?
Yeah.
Alright, let's go. So, how you been?
Good.
Alright, you want me one?
Nah, let's add an NPC, bro.
Alright, you wanna have MVC? Make it
Yeah.
more fun?
Yeah.
Alright, let's do that real quick. Alright, third player. What, versus race?
Yeah.
Versus race? Grand Prix? Okay, let's go versus. Alright, let's sign in real quick. Alright, let's get this NPC in. Alright, we good?
Yeah.
Alright, who you choosing by the way?
Let's see. I'm gonna choose Luigi. Yo.
You're gonna choose Luigi?
Yeah.
Alright, NPC's gonna be Yoshi, alright?
Yeah.
Alright, and I'm gonna be Mario, you know?
Alright.
Mario Luigi? Yeah? Alright, let's go. Alright, which club you wanna do?
Let's do Star.
When you start?
Yeah.
Welcome to the final race of the Star Cup. Thanks for tuning in. Let's review the rules of the race.
Sunshine Airport is a rose curve shaped circuit with 3 laps. The circuit is measured in the Mario unit system consisting of Mario miles and Mario feet. The 3 contestants will now choose their vehicles.
Let's go over the stats of each car now. Over to you, Toad Engineer.
Thank you. For today, we have 2 car options, the smaller GLA car and the larger Tanuki car. Both cars have a density of 8 pounds per cubic Mario feet, and both cars share a common width of 6 Mario feet. Let's look into the cars a little bit further to help the contestants pick.
Okay, so we need to find the volume of the car, or the volume of the car to find the weight of the car. And we are given the common width of 6 Mario feet, and the common density of the car, which is 8 pounds per cubic foot. Also, functions B of t, or B of x, models the bottom of the car, and the function t of x models the top of the car. So we need to split the car up into 3 different integrals, the red one, the blue one, and the green one. The red one can be modeled by 0 to 4 of the first part of the piecewise function of t of x minus the first part of b of x. Similarly, we'll do this for the integral from 4 to 14 and from 14 to 18. For the integral from 4 to 14, we can work this out by hand, separating it into 2 integrals, one for the top t of x and one for the bottom b of x, and then subtracting them. So we'll take the top function from 4 to 14, and we will first square out the x minus 9 to get negative 75 thousandths times x squared minus 18x plus 81 plus 6 dx. And then we will factor out the negative 75 hundredths to get this function, and then we can combine the negative 6 and 75 hundredths plus 6 to get just negative 75 hundredths. And then when we take the integral, we'll add 1 to the degree and then multiply it by the reciprocal of the degree to get this function here with the bounds 4 to 14. And then we'll plug in the bounds, b first, to get 62.65, and then we'll subtract the bottom bound, which gets 8.9. So the integral from 4 to 14 of this top part would be 53.75. And then we need to subtract the bottom part, b of x, which is modeled by the function y equals 1.8 from 4 to 14. So we can add in we can integrate this by just adding an x from the bounds 4 to 14 and plugging in the bounds to get 25.2 minus 7.2 to get 18. And then we want to subtract the integral of the top minus the integral of the bottom to get 35.75. And then now that we have the integral of the middle part, we can use Math 9 on our calculators to get the integrals of the first and last parts, the red and green parts here. And the integral of the red part would be 12.1373. And then we have the integral of the middle part that we just got, and then the integral of the last part would be 11.7390. Then when we add all these together, we get 59.626 square Mario feet to get the area of the car modeled by t of x and b of x. And then we can multiply this by the common width of 6 Mario feet to get the volume of the car, which is 357.758 square Mario feet, or cubic Mario feet. And then we know from the expression density equals mass over volume, that if we multiply density and volume, we can get the mass of the car. So since we know that the density is 8, we can multiply the volume that we solved for times 8 to get the total weight of 2,862 and 62 thousandths pounds. Okay, so for the second car, it's very similar to the first car in that we have two functions defining it being the top function t of x and the bottom function b of x. B of x for both cars 1 and 2 are identical. However, t of x on the second car is raised by 2 units. So we have to find the volume of the car first. So we can do this since we know the common width is 6 feet. We'll take the area between the curves for each of these 3 regions, modeled by these integrals from 0 to 4, 4 to 14, and 14 to 18. And when we put these in our calculators with Math 9, we get these 3 numbers respectively. And when we add them together, we can get the total area of the curves modeled by 95.626 feet squared. And then we can multiply this by the common width of 6 feet to get the total volume of the car being 573.758 cubic Mario feet. And then, since we know that density times volume equals mass, we multiply it by the common density of 8 pounds per cubic Mario feet to get 4,590.062 pounds for the weight of the second car.
Thank you, Toad Engineer. Now let's see which cars the contestants are picking. I think the less weight, the faster I can be. I'll choose a GLA.
Fine, I'll take the Tanuki cart.
It's me, Mario. It's me, Luigi.
Yahoo!
The starting grid is set. Mario in the GLA, Luigi in the Tanuki, and Yoshi on the bike. And we're off.
Yoshi is off to a quick start. Mario looks upset.
I'm winning today.
And there goes Yoshi as he leads the Star Cup around the first corner.
But I know these drivers will stay optimistic because there's a lot of racing and this is a 3-lap race. Look at Mario's intensity.
Yeah, he's really in the zone. Yoshi had a good start, but his bike is much slower than Luigi's Tanuki kart. I expect that Luigi will pass him very soon. Luigi's always been known to make his move at the beginning of the race.
There he goes. Luigi passes Yoshi and we are on to the second lap of the Star Cup. The order is Luigi in first, Yoshi in second, and Mario in last.
Yeah, you hungry? Yeah.
Now Mario is stuck behind Yoshi. If he wants to stay in this race, he's gonna have to pull something off soon.
If I want to hit Yoshi with the shell, I need to calculate the distance I throw it. Okay, I need to throw the shell now.
Oh my gosh! Did I see what I think I just saw?
Yahoo!
Let's get an instant replay of that.
Look at that precision. It looks so calculated. Toad Engineer, please explain this.
Got it.
So for this problem, we're going to use a final position formula. And so the final position formula is the initial position plus a to b, the integral of velocity. So we know we're trying to find the distance after 4 Mario minutes. So we plug in 4 for the end bound for the integral. So Yoshi's bike at t equals 0 is at 130, and Mario's car at t equals 0 is at the position 2, 4. So we know Yoshi's velocity vector is the 3t squared minus 4, and then 4t plus 2, and then Mario's velocity vector is 6t squared minus 2t, 3. So to find Yoshi's final x position, we use the final position formula. So we know at t equals 0, it's at 1. So we do 1 plus the integral of 0 to 4, the velocity vector, 3t squared minus 4. And then we integrate that, and then we plug in the bounds, and then we get 49 for the x position. And we do the same thing for the y position. So we do 3 plus 0 to 4 integral of 4t plus 2. And then we integrate it, and then we plug in the bounds, and then we get 43. And then we get Yoshi's final position at 49 to 43. And then we basically do the same thing for Mario's x position, y position. We know t equals 0, Mario is at 2. So we do 2 plus 0 to 4 integral of 6t squared minus 14t. And then we integrate it, and then we plug in the bounds, and we get 18. And then we do the same thing for the y position. We know at t equals 0, he's at 4. So we do 4 plus 0 to 4, 3. And then we integrate it, and then we plug it in, and then we get 16. So we know Mario's final position after 4 minutes is 18:16. And then we want to find the distance between Mario and Yoshi, so he knows how far to throw the red shell. And then we use the distance formula. So we do 49 minus 18 squared plus 43 minus 16 squared, and then we square root it. And when we plug into our calculator, we get that the distance is 41.11 Mario feet.
Thank you, Toad Engineer. This race is really coming down to the wire as we go into the third and final lap of the Star Cup. Let's see what Mario can do going into the final corner.
Luigi's car is faster than mine. At this rate, I'll never catch up. Unless I cut him off and take the inside route. lowering the amount of distance I need to cover. Then I might be able to keep up and overtake him.
Oh my gosh!
Mario takes the lead going into the final corner.
No, how do you get in front of me?
How did he pull that off? Toad Engineer, please explain!
Got it.
Mario is trying to pass Luigi on the track. In order to do this, he needs to find which distance will be shorter, the inside of the track or the outside of the track. You can see that these two formulas represent the two sides of the track. For the inside of the track is represented by r equals -7 cosine of 3 theta. drd theta equals 21 sine of 3 theta. We have to use the arc length formula of the integral of a to b of the square root of r squared plus drd theta. For the inner curve, the bounds are pi over 6 to pi over 2. If we plug in these two to the equation, we get a total distance of 15.5924 Mario miles. If we do this for the outside of the track, and the bounds are 0 to 2 pi over 3, and we plug in the r and drd theta, we get a distance of 20.2956 Mario miles. As you can see, the inside of the track is a shorter distance than the outside of the track, meaning if Mario took that route, he would beat Luigi. Thank you, Toad Engineer, once again. Let's head to the finish line to witness the final stretch.
There you have it, folks. Mario comes in first and wins the Star Cup. Luigi comes in second place. Let's check that replay.
Hey, let's go. Let's go, man.
Oh, we almost forgot about Yoshi. The blue dino walks across the finish line to take third place.
You can really tell how upset he is, especially after that phenomenal start.
Man, I hate this game. That's it. Good elaborate.
What food?
I don't know. Alright, I'm gonna do the celebrating one.
Yahoo!
Okay.